Hello, welcome everybody to another ClearEdge 3D webinar. Today we've got some really great people with us to talk about Verity and using that out on construction sites. So we'll take a quick look at some housekeeping stuff first. So we will keep everybody muted during the presentation. If you have any questions, please ask those in the chat window. We have some wonderful people that will be keeping an eye on that chat window and queuing up questions for the end, which is, of course, when we will take them. And yes, the webinar is being recorded, and we will send out a link to everyone who registered for the webinar after the fact. I should also note that I have a 9-month-old daughter who is not quite out of the room, so if you hear any screaming, that is not an unsatisfied Verity customer. That is just life interjecting. But hopefully my wife will pick her up in just a moment. So with that, we'll talk about the goals today. So we want to help kind of everybody understand just the QAQC problem in constructions. This is something I'm pretty passionate about. That's why I came on board at ClearEdge. This is a big issue with the industry, at least in my opinion. We're going to show you why scanning by itself is not enough to solve it, and how new software from a number of vendors is really geared towards trying to tackle this particular problem. And then at the end, we'll kind of talk about how you all could get engaged, either to leverage Verity out in the market yourselves, or even, if you're interested, be a reseller for the technology. So that's pretty much the goals. The agenda here, you'll see pretty much in line with that. And with that, let's get on to introductions. So our esteemed guest for today is Kyle Hudson with Viatechnic. He's a project director there. You can see all sorts of interesting stats on the screen here about him, though I think we should all feel, I don't know, a little sorry for him, because I'm not sure the Cubs are going to win tonight. Kyle, you want to say anything?
We're past Steven Strasburg, so I feel like we're past the eye of the hurricane. We can do this.
All righty. Hope springs eternal. Excellent. All righty. And then we also have myself, of course, and many of you are familiar with me because they always put me up here now that I've joined the company. And then we've got Tim Lowry, who is our Chief Revenue Officer, and interestingly has worked with a computer chip manufacturer equipment company. So he's got a really interesting background, but also a baseball fact, apparently still can't hit a curveball.
As long as I can hit him like Didi did last night, I think it's fine.
Fantastic.
If anyone saw the Yankees Cleveland game.
All righty. Well, with that, let's move on and talk about the problem that we've got here. So, if we look at a high level across the industry, and this is based on numerous surveys from numerous companies, 5 to 12%, anywhere in that range of a construction project's cost is wasted on rework, schedule delays, downstream issues that arise. This is a big part of the inefficiency of the construction industry overall. And I know, Kyle's got some great examples from my past life working with the Bet Group. I've got some great examples. We've thrown a couple of them here up on the screen. One of my favorites is this lovely little valve rack that you see on the left that actually just got installed, rotated like 180 degrees. And so all the valves did different things, and they never updated the as-built drawings. And this is going to get turned over to an owner who's going to operate this building and has no clue what the valves do. And in fact, if they look at their drawings, they'll do the opposite thing. These kind of things are just everywhere in the industry. I know you've got this image up here, Kyle, of the rebar. You want to talk about that a minute?
Yeah, I mean, this was a linear accelerator vault in the hospital. It's really advanced designs. The problem with these things when they build linear accelerator vaults is that the final design happens much later than the CDs are issued for the rest of the hospital, and that's pretty much standard. It just takes a long time for like Johnson Controls and other various manufacturers of the specialized equipment to do final designs. Meanwhile, contractors are trying to build kind of the outline and framing of this room based off of what they have, kind of working off of, pre-shop drawings and post-CD plans related to the linear accelerator. So what you end up with is contractors placing rebar early, starting to pour too early, and then boom, a final Johnson Controls shop drawing gets released and everything changes. It's something that can be modified in the field to work usually. The changes usually aren't too crazy, but it's really important that, these 3-foot thick concrete walls surrounding linear accelerator vaults are built properly with the right reinforcements. So, scan and verification during design change, like late stage design change is huge for these specialized rooms.
Yeah, it's a great example. And I think, what I saw over and over again in my career was just this problem with, you have the drawings, you have this coordinated information, and things don't necessarily get built exactly the way it's intended. And then you have these design changes that you're talking about that come down the line, and everybody scrambles and makes assumptions that what was built before is actually what was supposed to be built. And then you go through this whole process of adjusting, and then you get out there in the field, and then you realize, well, it wasn't even built there quite anyway.
Yeah, so it's weird because, in this hospital project, for instance, we had 26 CCDs, okay? So on CCD number 26 that came out, the architect is thinking that everything had been built per the previous 25 CCDs. Well, is that truly the case? Not really, right? Because everything is happening in real time. So it's very difficult to keep up and verify as you go so that you can incorporate these design changes.
Absolutely. And it kind of reminds me of the example I've got in the middle here is just this interesting steel job where the drawings weren't maybe as clear as they could have been. And there was a column that was basically omitted at the mid-floor of a building. So there was a column on the first floor, a column on the third floor, but there was, they basically had one level where it was missing, and there was a transfer beam and all this other stuff. But the drawings, just because of the way they were done, it wasn't clear which level was supposed to be missing the column, and they got it wrong in the field. And you can actually see here, there's this beam with all these penetrations that needed a column for support, and they didn't have it there. And these beams were actually, sagging, I think like 75, 80 millimeters at this point, just because of all the extra load and not having a column support. But this kind of stuff, it happens. I mean, this is an extreme example, but it's pretty wild. But if we take that number 5 to 12%, and let's stay on the low end, if you look at the global construction industry, which is $10 trillion annually, that means like every single year, about 450, 500 billion is lost in waste, and that's lost profit, that's lost to all the different players in the industry, or extra cost for the owners. And that's just a lot of money for every single year. And it's due to these kinds of issues. It's a pretty big number. I mean, this is another really simple example of just an embed that was put in the wrong place in the field in a slab. And what exactly is that column supposed to sit on now? There's just all sorts of stuff like this. And so, with that, let's take a minute and kind of talk about how QAQC is really done in construction. Because I think, a lot of you listening in probably know this already. But it's for those that don't, it's I think interesting. So 99% of the industry relies on a methodology called spot checking. And the whole concept is that you take some percentage of the work, 5%, 10%, and you go out and you check those individual things that get installed. And then you look at how closely all of that matches what it's supposed to. And if that 5 to 10% is pretty good, if it's good enough, then you just don't worry about the other 90 or 95%. You hope that that's going to be, statistically similarly installed. And a lot of times this is done, shoot with a tape measure pulled off of chalk lines in the field. In more sophisticated cases, we're at least using, optical surveying equipment, total stations to take these measurements and check work. But it's pretty crazy to think, this is still how we're checking work, in 2017, when we're building these massively complex buildings with all of these interesting systems and infrastructure that go inside of them.
What's weird too is, I've got smaller GCs that we work with that even struggle to hit a 5% type of spot checking. They're really relying on the BIM essentially to do everything. Like there is no spot checking. They're relying on their subcontractors to install per the BIM, and they leave it at that. Their project engineer, they got one project engineer on site, one project manager on site, and maybe a super. Those guys are tied up doing other things. Now, obviously, larger buildings, larger companies, yeah, hopefully there's somebody going around and trying to get to that 5% or 10%. But I know for a fact there's jobs out there that are much closer to zero, which is very risky from a GC and a CM perspective.
Yeah, no doubt. And the other thing that bugs me is that, spot checking is actually a kind of statistics-based methodology, and it assumes, to be effective, that 5 to 10% is random, right? And what we see instead so often is that, as a GC, or even the subcontractor, you're really worried about specific things, right? And so you don't actually do a random sample spot check. You only check the things that you're worried about. And what's really dangerous there is the subcontractors, the people installing the work, know what you're worried about. And so those are the things that are actually the most likely to be installed correctly. So you're actually only checking the stuff that's most likely to be right. And you're completely ignoring all the other stuff. This was one of our beta customers, DPR, a friend of mine, Tim Malice, worked on this job. And the original intent was to actually go around and spot check all of the perimeter beams. They weren't worried about the interior beams. It was the perimeter beams, because that could affect the cladding and the waterproofing and their prefabricated glazing. And, they ended up using Verity on this job. They went out, scanned everything, checked everything, and they did find some issues on the perimeter that needed to be resolved. But the actual highest cost issue was found right in the middle of one of the upper level slabs. It was a slab that was supposed to be sloped, but the structural drawing didn't have a slope annotation on it. That was only on the architectural drawings. And of course, we all know steel fabricators never look at architectural drawings. So they fabbed and installed this area flat. And, they caught it on this job before they had rebar down, before they poured concrete. So like their total cost to fix was just, under $10,000. But if they had rebar down, poured concrete, if they had found this just like 2 or 3 days later, then this would have been a $50,000 issue for them. And that was an area that they were not going to check initially because it wasn't a big concern. And that's just common practice, I always find that interesting. You run into anything like that, Kyle?
Well, I think you started to talk about this slide. What I was reminded of is also what's easy to check and what's difficult to check. So you're right that like subcontractors know what should be checked to kind of COA, right? to kind of, because that's what the GC is looking for. But also, if you look at some of the slides, like right here, like this second from the left, there's ductwork that's very easy to check in this scenario. And there's some things above and around the ductwork, the conduits, for example, that are super difficult to check. So that brings another element to it. If I'm the GC or a project engineer walking around site, I've been tasked with spot checking. What am I more likely to spot check here? The thing that's going to take me 2 or 3 minutes, or the thing that I'm going to have to go grab somebody to help me with, to get PPE, to get a ladder, and it's going to be a nightmare. Got to keep that in mind too, which, you know, it's difficult. What can you rely on, you know?
Yeah, absolutely. And, you know, this is, of course, why I think a lot of people are already in the industry looking to laser scanning, you know, to help solve this problem.
Yeah, it's like, why would you rely on a young PE or a PM to make the decision on what to spot check when you could just kind of try to grab everything? And you talk about like layering and stuff, you know, duct work underneath of electrical, underneath of fire protection, and you're putting yourself in a really difficult situation if you're going to rely on humans to kind of grab that data for you accurately.
Yeah, definitely. But, you know, I think the thing that we've heard and seen a lot of in the last couple of years is that it's a really great idea, you know, scan everything, measure everything. But then you kind of run into this problem. This was a job that I worked on at Beck, and we wanted to kind of do a QAQC pass on a central utility plant. And, you know, this was the idea, right? Oh, let's go scan everything, bring it in, we'll look at it, we'll compare it. We pull all the data together. And then I realized that this is going to be like the worst, most boring week of my life ever.
Yeah, I feel like we all have those where it's like Monday and you're like, oh man, I got 5 days of this ahead of me.
Yeah, so I've got to go through here, follow run by run, look for all the piping, see what's, and you know, you can see stuff's wrong, of course, right? It's, you know, over in this area, right? Yeah. We've got clearly stuff that's in different locations, but God, you know, trying to figure that all out, you know, the bottleneck, you know, really is that time to actually interpret the data and understand it. This was one of your examples that I really liked.
Yeah, I mean, this is an interesting situation here. You've got an extremely dense rebar and post-tension concrete situation. We've taken the time to model it. You know, we've taken the time to clear clashes against rebar so that the rebar can be installed correctly and easily in the field. And now, as an engineer or as a DOT, this is for a bridge, is a V-pier, about 40 foot long by 8 foot wide V-pier supporting a bridge. If I'm the DOT and somebody has taken the time to painstakingly model and coordinate all the rebar and post-tension ducts in here, how do I now go out and verify as an inspector? You know, every bridge job in the country has an inspector on it pretty much. And if I'm the inspector, what's my strategy here? How do I even start? I don't remember the weight of rebar in here, but I honestly, I think it was in 80,000 pounds for a single V-pier, somewhere in that range. So, you know, do I look at the large bars? Okay, like we talked about earlier, you know, the large bars are probably set correctly. What about the stirrups? You know, what about the hairpin bars that chase the tendons around? Those are just as important and can, you know, cause some really significant concrete deterioration if not placed properly. So what's my strategy for inspection here? If I scan it only, I'm going to end up with this crazy point cloud that it might not even be discernible to the eye what rebar is really what. So, you know, using Verity on a case like this would be really exciting for me. I haven't had the opportunity to use it on like a bridge type of situation like this, but I think it'd be a really cool application and could significantly improve and cut down on inspection time.
Yeah, and this is, you know, one of our other early beta customers had a really interesting kind of workflow for checking slab penetrations, and of course you had a you had a slide earlier that showed some slab penetrations.
Those conduits, yeah.
Yeah, exactly. And so, the interesting thing, right, is that this is a pretty serious problem on almost every job. Are these things in the right place? Because if they're wrong, now all of a sudden you're moving walls, right? The impact that a penetration in the wrong place has is pretty big, and coring is not the cheapest thing in the world. And if it's a PT deck or something, you really, really don't want to core, because now you've got to get an X-ray scanner out. There's all this stuff that goes with it. And so they were actually scanning the slab or the metal decks prior to rebar or concrete going in on every single pour for this building. And then for that pour, it was taking them about 8 hours to visually fly through Navisworks and check every single penetration just visually. And so that was a fun one for us, because we helped cut that down to under an hour per pour.
That's really interesting you say that. I literally have a project right now where we're in the BIM coordination phase. Nothing's been built yet, but I'm going through that riser coordination stage, and it is a nightmare coordinating risers, using Navis, using Revit, all the tools that are available to us. We finally got the risers set after 5 weeks of coordination, which is just way too long. We haven't even started overheads yet at this point. So to your point, it's I spent all of that time and effort getting my risers nailed down. Now it gets out into the field in 2 or 3 months. We're going to start building these slabs, and these are pre-tension precast slabs. So it gets out into the field. If something's off, I don't want to have to go back to that 6-hour, 8-hour Navisworks process. I really would like it to be easier and quicker.
Yeah. Well, that is, of course, the goal. So, this we're certainly not the only ones. A lot of people have seen this kind of trend in the industry to look to reality capture as a really effective data input into the QAQC process. And kind of the two big ones that are commercially available right now. We've got our software, which is Verity, and of course, many of you may have heard of SCUR. And they're both really good tools to do this that take a little bit different approaches to the problem. So with Verity, we take objects and we transform them, move them into place against the point cloud, and use that to get metrics and measurements. All this is run on desktop software. You kind of review each one, and then you go through a reporting process, and this is all kind of happening locally. And what's really neat about SCUR is you basically upload all of your information into the cloud, and they process it on their end, doing comparisons between the geometry and where the points are. And so they send you back reports that have measurements from the geometry to the points, and kind of identifying where things are out of tolerance. So the end result's pretty similar, but the business model, the way we get to them is pretty different between the two products. But we're always happy to not be the only person seeding a market, because they have their own webinars and letting people know that this is a really good, valid way to kind of solve this QAQC problem. The beauty of it is that you can kind of move away from spot checking and get towards where you're really trying to check 100% of the work, or at least of a particular scope of work. I mean, you may not want to check every hanger or every conduit, but being able to identify particular things and check all of them is a just fundamental shift in the risk profile for a general contractor. And whether it's schedule risk, cost risk, it all has a direct impact. And with that, I do want to hop over and do a live demo. And just to prove to everyone that I am insane, I am going to do that live, and I'm going to do it with an unreleased brand new build of the software. And so the last time we showed Verity publicly, it was the 1.0 release. And while the core of the software is still the same, we've made a lot of nice little tweaks and improvements over the last few months, and I wanted to show some of that. So hopefully this does not blow up in my face. And if it does, Kyle, you can laugh and do a little something.
I'm already kind of laughing.
To distract people while I pull it back up. All right.
This is awesome.
So
Godspeed.
Thank you. So this is showing off our 1.1 version, which will be released, knock on wood, in really just a matter of days now. Fundamentally, the way that we work with Verity is very similar to the clash detection process. If you've run Navisworks, if you've run a clash detection, you already know how to use Verity. You just click different buttons. We start out by identifying what it is that you actually want to test. And you can do this with search sets, selection sets. You can do it by manually picking geometry, window selection, whatever you want. You go grab stuff. I could go grab all the structural steel, for instance, or all the architectural walls. For today, we'll just grab a kind of limited set of items so that we can kind of take a look at the results pretty quickly. So I'm going to grab about 15 different types of objects and just a couple of the scans that are in this project. And I'm going to add those in to Verity. So this is kind of like that nice clash detection window where you've got the two sides and you're saying, what do I clash against what? So we've got our 3 scans, we've got our 15 objects, and all of that's going to come in so that we can look at it and kind of inspect it a little bit before we commit to running the analysis. Now we'll split screen it here. Excellent. All righty, and we'll take a look at our first pipe here. And so, one of the nice things is we do kind of maintain selection between the two. So if I pick a different pipe, you'll see a different pipe is picked. And then one of the new features I'm really, really happy about is this match view frame button, which will then basically shift me into a mode where whatever I do in Verity, it'll match in Navisworks. So it gets real easy to see.
This kind of reminds me of like sync in Bluebeam. You can sync 2 PDFs. This is awesome. I haven't seen this yet.
Yeah. This is one of the reasons why I wanted to do the the current build. So this one's this is a nice feature. Really helps you understand your relationship to the object across the application. So anyway, with that, let's go ahead and analyze everything. All right, set some default parameters. Go. And so really at this point, what Verity does is it's going to take these 15 different objects, look at each one. It's going to grab all of the points from those laser scans that are around it. And we're going to do 2 things. We're going to first try and determine if that object has actually been installed. We do that using some fancy computer vision algorithms that our founder and CTO wrote. I could not even begin to explain them. Then we're going to also, if the work is found to be installed, we will fit a copy of that Navisworks geometry to those points. So we'll basically grab it, copy it, move it around until it matches up with those points in a mathematically optimized way. And what this gives us, of course, is 2 pieces of geometry that we can do comparisons against and take measurements from. And all of this is kind of happening within a zone. One of the things a lot of people ask me is, well, why can't you just search the whole project and find where it's installed? And I'm like, well, there's a lot of 2-inch pipe in a job. And if we don't kind of limit it to where that thing is supposed to be, we're going to find a lot of matches. So yeah, we kind of make the assumption that it is close to where it's supposed to be. They tried to install it correctly. Otherwise, we'll say it's not found. We also need the point cloud data to be at least, pretty clearly defining the same shape as what's modeled. So if you've got a square penetration and it was modeled as a round penetration, we're going to have a hard time with that. So just kind of give you an idea. Now, once our processing is done, this is also a new report. We're going to give you this lovely little summary report that kind of gives you an overview. It's much more impressive when you analyze 300 elements than 15. And then we've got some data at the bottom that helps you look for bias in that data. So is there a control bust maybe, or did one particular trade get all of their stuff shifted over an inch because they pulled off the wrong control point? So really useful information to help you diagnose and look for that kind of data. And then within Verity, of course, we've now got our two objects. And I'm going to pop this up full screen here so we can all see everything, but do bear in mind we have that kind of live connection back to Navisworks, which is really useful for a lot of things. But we can all see now two pieces of geometry. The purple, that's where it was supposed to be. The cyan color, that's where it actually is. You can see the points there. You can rotate this around, look at it. Because we have the two pieces of geometry to measure against, we can provide things like horizontal and vertical rotation of the object. So we can see that this was rotation from vertical is about 1 degree on this particular chilled water pipe. So they put that in a lot more sloped than intended. We can also look at translation. So is the pipe shifted along its length or kind of in section? And then kind of going back to the project coordinate system, so plus or minus X, Y, and Z. And then we'll give you a worst case total translation, and that's what gets compared back to this tolerance that I typed in when I clicked analyze. So based on that, we will say, yes, this pipe's installed, but it's out of tolerance because of that 7.425 inch discrepancy. And all of that's done with no user input. It's just checked. And for things where it is installed close to where it's supposed to be and the geometry is a good match for the points, you're not going to have to do a whole lot of work to go through a QAQC process. And we have some other good tools to just kind of interrogate the object. So we can, for instance, turn on a heat map and have an understanding of this, how good the fit is. Does that particular object bow or bend in any way? So go to maybe 1/4 inch here, and we can see that it's got a little bit of a deflection here on the insulation wrap around this chilled water pipe, which nobody cares about because it's insulation wrap. But easy to look at the data and work with these to kind of understand those things, though. All righty. And with that, let's take a look at one or two other things here. So obviously, I did mention that if things are not quite the same shape, then the algorithms that we've written are going to have a little bit of a harder time with it. And so this duct is a great example. This thing was wrapped ahead of time with insulation before we scanned. So this kind of thing you will have to make manual adjustments to, but you can see that it's real quick and easy to make those adjustments because we kind of slice and dice this data in these different viewports for you. Then you can go update your heat map and kind of move on to the next thing. And then again, if you get cases like this where you have, oh gosh, there's two identical pipes side by side. In this case, they did install it close, so we found the closest one. But gosh, what if they got it wrong? Well, what if it's actually the one over here? You can go in and make these adjustments again manually, and then actually refit the geometry using those same fitting algorithms, basically saying, hey, you guessed the wrong one. There's duplicates. It's this one over here. So all really nice and easy to work with. Go through, kind of quickly review your whole list of things that you tested. And then we've got some really cool reporting features. So summary report we already took a look at. I'm going to go ahead and sort by tolerance here and then deselect everything, we have a kind of detailed HTML report that you can spit out. And this will give you a really good idea of, every individual object, but it's in a format that you can view on your phone. It's a format you can send to your principal or to your project executive, and they can pull it up on their iPad. So it's really, really useful information, but in a very light, easy format. They don't have to have Navis or Verity installed. And I, of course, managed to put it in the wrong folder. We'll do that again real quick. And I'll pay closer attention this time. There we go.
Just out of curiosity, what did your report look like when you did this the first time at Beck?
Oh, gosh. This one was a tough job because like the HVAC and the structure were all pretty good. I mean, it was a lot of it was out of the specified tolerance, but it was, within, at least a couple inches. And so it was, for those things, it was really quick and easy to go through, do the review, say, yes, they did a good job. And then we got to the mechanical piping and just the water supply piping, all that stuff. And it was like they had completely just like used the drawings as Kleenex, or something else.
Okay.
I mean, it was just so much of it was field fit and installed, and they didn't update their as-built drawings. And so it was just, the big stuff was close. Again, like these chilled water pipes, the big stuff was, pretty close within, 10 inches, which is kind of terrifying that that was close. But the little stuff was just all over the place. That valve example that I showed earlier is actually one of those. That's one of them. They just completely rotated the rack of valves. And
yeah, it just seems so hard to create a report like in PowerPoint or in PDF or in Word, manually, I guess, using Navis. I don't know. I wouldn't even know where to start, I guess.
Yeah, it's a tough thing, but this is what, we were kind of able to get out of this, right? Was you get a table of elements, you can sort by whatever you want to sort by, you've got all the relevant information, and then you can go take a look at something, and now you've got, the images associated with it. You can really see what the issue is, all the data. So this is, a really fantastic way to kind of get that information out to people. And then we also have a really nice report. This one's kind of my favorite for closing the as-built loop. And this is our smart points. So what this does is take all of the objects that we go to the right folder again. Boom. All right, perfect. Takes all of the objects that you have picked, and it exports just the point clouds associated with those, nothing else. So this gets you a really nice small file. So you'll see this is about a 3 megabyte point cloud file. So you can totally email this off to somebody for a small central utility plant. And then it also, colorizes it and makes it just kind of stand out. So we'll create something up here. Let's see, that is the correct one. That's fine. And again, most people would be like, "Oh my God, you never are going to index a point cloud while you're on a webinar." But I'm going to index a point cloud while I'm on a webinar because it's 3 megabytes. All right, and there we have it. So that now is the heat map point cloud of all of the out of tolerance elements. So you can imagine sending this to your trade subcontractor, to your engineer, to your architect, and saying, "Hey, here's the stuff that's different in the field, and you need to update your as-builts to match." It's not like you're sending them a 20 gigabyte point cloud file and saying, "Figure it out." So it's a really, really effective way to communicate.
What does green indicate in this scenario? You said all the points are out of tolerance, but green is...
Yeah, so in this case, I use the Asbuilt Heatmap, which maps the
Yep.
points to the surface, right? So if we, that's a great question. So if we take a look up here, so what this is really telling us is that object deflected or bending, or, with a floor, for instance, is there a high spot or a low spot? So all of that is, in this one, but we can also look at our as designed heat map. Which in this case you'll see that is all red because there is no point on this that is within the tolerance. So if I were to go and export the as designed heat map out, yeah, everything would come in red, and it's kind of like a big red pin in point cloud form. So it's definitely a nice nice tool for depending on which one you want to do. And then the last stuff, and this is my favorite part of every demo. Is showing how we can kind of, again, go back to Navisworks and work with it. So if you kind of take a look at this pipe here, and I'm going to deselect it in Navisworks. If I push properties over into Navisworks for this object, I'll actually colorize it. And so that applies our color schema for installed, missing, passing, out of tolerance, etc. And it also pushes the properties over. So if I now pick it, you'll see all of the different properties that are in the Verity table here are now in Navisworks. You can use it with appearance profiles, search sets, all that kind of fun stuff. Filter this back into your own reporting tool that you've got in Navisworks if you're using, BIM track or, oh gosh, I'm forgetting the other one that's really, really common, iConstruct. So that's an easy thing to do. We can also actually as-built the Navis model. So I'll do one thing real quick here so it's a little easier to see. All right, perfect. So if I take that particular pipe and hit this magic button up here, you'll see that it just actually dropped that down to match the point cloud in Navisworks. So we now have an as-built Navis model that we can run through the Clash Detective to validate, that this discrepancy between the intent, the fabrication intent and the actual installed work isn't going to cause a clash for somebody else downstream. And we don't have to do this one by one. We can also actually enter a mode where we're synchronizing Verity to Navisworks. So by locking that button down, you'll see now everything that we tested is now colorized. Green is passing, yellow is out of tolerance, red is missing. And then that way we can kind of work backwards and forwards and try and understand what's going on with different geometry and kind of use Navis as part of that QAQC tool.
I think this could be really, really useful for that layering example that we talked about earlier, where an electrician installs something slightly off the BIM, ductwork's not installed yet, fire protection isn't installed yet. Well, now we have to decide, is it even really an issue? Like, do we even need to, bring this up as a big deal and have them tear it down? So if you can move it in Navis and then compare against the ductwork that's coming next week and the fire that's coming the week after that, maybe it's not even a big issue, I think that's really cool that you can go back to the coordination model and check it out.
Absolutely. And again, you can move this into a synchronized mode, push for multiple elements. So I just as-built all of the out of tolerance elements. And this is going to give you a lot of really useful information, for kind of downstream purposes. And if you're lucky enough to have an as-built requirement in Navisworks, you can actually hand over an as-built model now very, very easily. If you've got to go back to the authoring files, obviously that Smart Points export is a really great way to get those authoring applications done. And this is not changing anything in the Navis model. If I go to any one of these elements, I can grab the pipe here, go to the item tools, and just hit reset transform. So we're just, changing the transform. The source files are unmodified. So we're not polluting the data. But yeah, and that's pretty much what I wanted to show today. Oh no, there's one more thing because it's new and it's super exciting. I can't believe I almost forgot this. So we also have the ability, let me drop out of this now, to take measurements between the surface and the points of that as-built model. So if you are looking at deformation and you kind of want to understand, find a good example. This will work. And you want to kind of understand, you know, how far out are we? I wish I had a good floor flatness example because that would be really cool for this, but we'll do that. 0.25, go to our as-built, and we kind of want to understand, well, you know, how far out are we at this point? You can pick this tool, click anywhere on the surface, and we'll actually take an average measurement at that location across all the points in that zone. So you can see that this one is, 0.169 inches plus or minus 0.003. So you can get a really good understanding for the accuracy of the point cloud, the accuracy of the install, and whether that object is deflected or bending a significant amount. So here we can see we're a little outside of that 0.25 inch tolerance that I typed in. So another fun addition there. We also added stepped gradients. So again, if we were to look at a floor flatness example, you can set those steps to be a number. You can also step them to actually just be a size. You could do 1/4 inch color changes or 1/8 inch color changes, whatever you want to do there for documenting. So that's pretty nice. So. Alrighty, with that, let's hop back to our slideshow. And turn it over to Tim.
Awesome. Thanks, Kelly. Thanks, Kyle. It's a great demo there. I'm looking forward to the new release for sure. Great examples you guys showed and talked about as well. Now that we have a better understanding of the issue or the problem in the industry and why it's so costly. This is Verity, something that we've been working on for 2.5 years or more probably. And one of the things we did in the beginning was go out and figure out what makes sense for us to do in terms of how do we address the market and so forth, because we have a lot of customers and companies coming asking for some help with regards to help validating projects and such. So going out looking at the size of the market, as you can see some of the data point here in this slide, a global construction market value of about 10.3 trillion, huge market. And the US really comes in about 1.73 trillion of that, specifically in the US. And if you look over to the right, you'll see the top 5 countries. US is number 2. India is coming on really strong, and China obviously is still number 1. In the marketplace. You could also see the active construction projects that are going on currently, about 563,000. And then there's another 130,000 that are actually in the planning phases of those projects as well. And in the US, there's a total, just looking at just the number of construction companies out there, just gives you the good sense of how big this market is and where there's a lot of opportunity to address this, particularly with the Verity software. And so with that said, Kelly can go to the next slide. So let's talk about one of the reasons that we set up this call is really, talk about how construction verification as a service and how that Verity in particular can help drive new sources of revenue for companies and so forth. So the opportunity that we want to talk about today is driving more scanning dollars into the service provider, particularly into the service provider market through construction verification. Number one, go ahead and hit the next, Kelly, and you can go ahead and hit it again. I think it's one more time. So as a service provider partner, something brand new that we've set up, and we're basically using this webinar to introduce this to the marketplace. The goal here is really to provide a low barrier of entry in terms of working with us to help promote and push out the Verity software application into the GC space. And most of you guys are already currently working with a lot of GCs and engineering companies where promoting the Verity software is going to be a way to get the brand out there for ClearEdge, but is the advantage to us, obviously, and the advantage to you is actually providing the ability to give that other 50% of the solution to the scanning piece to your customer, whether it's either doing it as a service yourself or being a reseller for ClearEdge, selling Verity specifically, and we'll give you like a 25% commission basis on that. Now the software is selling about $6,000 a seat. There's two types of Verity reseller partnerships that we've set up. We've had these for years, actually. Number one is a referral partner, and basically it's a lower percentage, but you get a commission referring someone to ClearEdge, and ClearEdge team will come in and go in and try to close those, and we close that from your referral. Then obviously we'll cut you a check for the commission on that, and at least 10% of commission just for making the referral. The second part of that is the value added reseller, which is a typical reseller structured program. Generally, it's a upfront fee to start up. We're going to waive that with this program. We're also going to set you up at a 25 points, which is a standard discount for resellers. Next slide. Now, what else we're going to throw in there is sweeteners to this deal, whether it's reseller or service partner, either way, that anyone who wants to work with us on this. We're going to provide free training and support, not only free training and support for you as our partner, but also free training and support to the end user, to the customer. We think this kind of alleviates some of the objections to trying to help and support the software in the marketplace. We set this up to be almost free. What I mean by that is it's going to be free to get started, low barrier of entry to use of the software as a service provider. So we have a whole different structure for the service provider. It's going to be about a $1,500 cost up front. We'll give you 3 months off to start off for free, and then you start off at $1,500 a year at that point. And we'll also another piece of that puzzle is something that we could also talk about that actually is another cost sharing, revenue sharing option that we'll talk about as well. And I like to generally do that on a one-on-one basis because it's just to make sure that everyone's clear on how that's going to work. So any questions or any interest in this type of format, please reach back out to us at sales@clearedge3d.com. The other things we're going to do is free marketing support. We'll come on, we'll do joint webinars with you like this. We'll provide you enough collateral, data, market data, and feedback and so forth that you want to help support and promote the service. And then finally, we're actually in the process of building a brand new website. We're almost done with it, but we're going to be having a section on there, and we want to set up some preferred scanning provider designations. We all the time in the sales, we'll have guys come to us asking us for help with projects, who's a recommended scanner provider, and so forth. And we have a number of guys we work with on a regular basis, and we've have a good relationship with. So we'd add you to that preferred scanner designation as well. And with that said, I believe that's it. Kelly, the next slide.
Yeah, so with that, we're going to open the floor for questions. So any questions you have for any of us, again, pop them into the chat window. We've got people taking a peek at those in the chat window and then queuing them up for us to look through. So I'll kind of start at the top here and work my way down. So somebody asked, when there is a difference detected in Verity, can I approve the difference so I don't have to review it again in subsequent scans Verity runs? And the answer is there's a couple ways to do that, kind of depending on what you want to do. You can, if you as-built the object in Navisworks, the next time you run it, we won't see a difference. The other thing you can do is use the fact that all that data gets pushed into Navisworks, and you don't have to test the same things over and over again in the next runs. You can actually do a search filter to remove anything that's already been tested, so that you don't analyze it in the first place. All right. We also have a question about, does Verity have to work with Navisworks, or can it be used with Revit as well? And the answer is not yet. So we are working on a Revit connection. Don't have a specific date that's going to be released yet. Right now, it is an integration with Navisworks. That is the primary, really the only way to get data into Verity. And so somebody else said, we use Faro scanners and scene. In most instances, no matter how well we align point clouds, they don't match properly and need slight adjustments in Revit when assembling the project. It seems like there's no easy way to get those changes in point cloud alignments in Revit to Navisworks, which would make this entire process more error prone. So this is a great question about using control out on a job site and tying into project control. So we would always strongly recommend setting up targets on control points that are known and using that to align your scan locations. Because if you're manually shifting stuff to be a best fit, you're actually introducing noise into the data. If 2 columns are installed, a foot off, and then you best fit, in between them, it would show 4 columns that were out of tolerance or out of their install position by 6 inches, as opposed to 2 that were out by 12. So, it's a really gross example, but it's really important to have good survey control that you're tying into when you're scanning for construction verification. And there are ways that you can kind of get this in from Revit back to Navisworks. That's something I could always share offline if anybody's interested. Let's see. In this instance, how do you deal with point cloud alignment to make sure you're starting off right? So that same answer there. Okay. And then another question about point cloud coordinate systems that are used in the Revit model. So Revit can support multiple coordinate systems. So they have a project coordinate system and a shared coordinate system. Usually if someone is scanning on state plane, if you've got state plane or some kind of legal description coordinates out on the job site, you can set up a shared coordinate system in Revit that is basically equated to that, and then your scans can be brought in via shared coordinates. The other way to do it, and this is more useful with Navisworks because most people don't do coordination in state plane, is to find out what column intersections are in the kind of coordination control coordinate system. And any of the scanning and registration tools also support multiple coordinate systems. So you can basically, find those markers or targets, type in the value that is appropriate for the coordinate system you want to export to, and then redo your export. Kyle, what do you guys normally do in terms of coordinate systems?
Yeah, I mean, it really does depend. Sometimes if you're scanning like a boiler room, for instance, it's small, it's contained within a giant hospital. We're not going to go out and find a state plane and then transfer manually survey that over to a benchmark locally into the boiler room. So what we would do is set up a local control inside the boiler room on a column face or something and maintain that in Revit. However, if this is, a building that we're scanning, that's, going to be in either a larger coordinate system like state plane or some other, like a city datum, like City of Chicago has its own coordinate system, then yeah, we would use shared coordinates absolutely for that, so that our Revit model is being built on the project base point, but the scan data and therefore the Revit model being built on top of it is always using the coordinates of the point cloud, which was the city datum or the state plane datum. Does that make sense? That's kind of how shared coordinates work. So it really depends on the project.
Yeah. And the good news is there are always ways to get them to line up properly. You just kind of have to know what you're working with. So the easiest thing to do is to get the different models that you're trying to get stuff into, and you can pretty quickly figure out what route you're going to have to take.
Yeah, and going back to that question about moving point clouds manually in Revit, that's really never the option or the answer for us. It's always going to be an answer getting back to control. We actually tell our team to never move a point cloud. You're just not allowed to move the point cloud. If it can't be solved with control, that means it was unfortunately, an uncontrolled scan.
No, that was always a general rule of thumb as well at Beck. It was never, ever,
no
ever,
moving point cloud.
never. Always pin them and lock them. Never, ever move them. Put them on a work set and check out the work set. Yeah, it's
correct.
Yeah, it's correct. Usually not an error in the scan. It's usually an error some other way.
Correct.
But yeah, we had a quick question about the webinar being able to view on the web page, and if anybody came in late, this is recorded, and we will send it out to everyone within a couple of days. So if you registered for the webinar, you'll get a link to download it, and we'll of course have a link to that off our web page as well for people that didn't register. Let's see, we've got I'll take one last question and then we're kind of over time. So we have somebody ask, who is the client of construction verification service? I think the general answer there is it's typically the general contractor or a trade subcontractor, depending on what they're trying to solve. So if you're interested, like Tim said, in buying a license of Verity with that service provider business model, at the lower price point, but with a revenue sharing agreement attached to it, then you're going to be marketing primarily to general contractors and trade subcontractors that additional service on top of the scanning that you're probably already offering to them. All right. For any other sales related questions, you can certainly contact us at sales@clearedge3d.com. Get a hold of Tim directly. We'll be happy to kind of answer your questions in terms of signing up to be a service provider or reseller. That can all go to that sales@clearedge3d.com email. And if you guys have any technical questions or things like that and you want to reach out, my info, it's just kelly.cone@clearedge3d.com. So by all means, feel free to reach out to me. And thank you all so much for attending and your questions, and hope to be hearing back from you more on the next webinar. Adios.